In this video, we will decompose a vector as the sum of two orthogonal vectors, which are in specified directions. So just to draw a picture of what's going on here, we're given a vector v and a vector w. Let's draw them here like this. Let's say this is w and this is v. Then we want to write v as the sum of two vectors, one of which is parallel to w, so in the same direction, and one which is orthogonal to w. So really what this is asking us is to compute the projections, because the first vector will be this one. So this will be what's commonly called the projection of v onto w. That'll be our v1. And then v2 will be this dotted line that I drew. It'll go perpendicular to the red line in such a way that when you add them together you get the original v. So here v2 is what's sometimes called by this notation. Meaning the part of v which is orthogonal to w. Okay. So this is what we need to do. We need to use our formulas that we have for these two things. So first, let's do v1. So v1, as we've already said, is just the projection of v onto the direction w. And well, it's a vector in the direction of w, so we can write it as some scalar multiple of w, some number times the vector w. So we just have to remember what that number is, and there's a formula for it. It looks like this. You take the dot product of v and w and divide it by the squared length of w. So length of w squared. And this is it. This is the formula for the projection. So in our case, what do we have here? The dot product of v and w is 1 times 2 plus negative 3 times 0 plus 4 times negative 1. So 2 minus 4, that's negative 2. And let's see, what's the length of w squared? It's 5. So negative 2/5 times w. So this here is what is the red vector in the picture. Okay, this is our formula for the projection. Now, to get the second part, which again, sometimes we use this notation, the part of v which is orthogonal to w is simply the original vector minus the projection that we just computed. So in other words, take the original vector and just subtract the vector that we just got in the previous part. So let's see. The original v was 1, minus 3, and 4, minus this. So the minus signs cancel, so plus 2/5. 2, 0, and negative 1. And now we just do some arithmetic. So 1 plus 4/5 is 9/5. Negative 3 plus 0, and 4 minus 2/5, which we can write as 18/5. And if you like, I guess we could factor 3/5 out of everything, just to make it slightly prettier. And we could get 3 minus 5 is 6. And so again, just to reiterate, what we just got here is the blue vector in the picture. And so this is our answer. We've found the two vectors that add up to v, one of which, the red one, is in the same direction as W, and the other, the blue one, is orthogonal to W.